measurement. Suppose I am having a table. This is the table which has been placed on a floor, and I am applying some force on this particular table. So what is going to happen? This particular table is going to move in the forward direction. What exists this table to move in the forward direction is nothing but the parameter that has been exerted on the table that will try to move your table in the forward direction. So your force is defined as mass into acceleration. Mass into acceleration, sorry. Mass into acceleration. So mass is measured in kilograms and acceleration is measured in meter per second square. So the unit for force is nothing but Newton. So this particular terminology, that is kilogram multiplied by meter per second square, is nothing but Newton. So Newton is the unit for your force measurement. So we people will go thoroughly with this particular point for the measurement of force and torque measurement. Now, the contents that we people are going to study is introduction, then different methods that has been used to measure the force, and what are the different references through which we have studied this particular aspect. The objective of the lecture is, in the first lecture, you people will be able to understand the concept of elastic element, a basic, very basic point related to strain gauge and load cell, and after completion of the entire lecture, you people will be able to explain, or you people will be able to elaborate the force measurement using different types of sensors. That may be your electrical element, that may be strain gauge, or that may be load cell. So this is nothing but this is the objective of the this particular lecture or the learning outcome. So what is force? Force is nothing but it is the resistance or a hurdle to any moving body, or that may change a motion of a body, leads to produce this effect. Now, if suppose we are having one particular movement, that is a table, and on that particular table, if suppose I have applied some force from both the sides. Now this is the table which I am having. From this particular side, I have applied a force F. From this particular side, I have applied a force F. Suppose this is 2 Newton force and this is 3 Newton force that has been applied on this particular table which has been mounted on the floor. Now what is going to happen? Force, I will specify this one as F1 and this one as force F1 is greater than F. So what is going to happen? Definitely when force or the strength which has been applied from the right hand side is more compared to that of a force that has been applied from the left hand side. So the movement of your table will be in this particular direction. Now again, if we try to take the another example to hold the condition of the table, at that time what is going to happen over here is if suppose the table which I have considered, that table, here I have applied a force F1 is of 3 Newton, and from this particular side a force F of 3 Newton. What is going to happen? This will try to hold the condition. This will try to hold the condition, means this is not going to move to any particular direction. Okay, it is going to remain same. But if there is a variation, then definitely you people are going to get the different resultant output based upon that particular concept. Okay, so the technical definition is produce a resistance to any moving body, or change a motion of the body to tend to produce this effect. So force is measured applying it to a calibrated device that resists the force and indicates or records its magnitude. I will show the example based on this. So an influence that causes an object to change its rate or direction of a movement or a rotation. So force can accelerate a object by pulling or a pushing them. Now pulling or a pushing. So what is pulling? Suppose this one. If we try to move, you are standing at this particular side, and if you try to catch hold of this one and try to move, you are pulling it towards it one. And if you are standing over here and applying a force from this particular side, you are trying to apply a force, means you are pushing that one to the forward side. So this is the actual concept for this one. Now, what is the relation between force, mass, and acceleration? As per the Isaac Newton specified in his second law of motion. So that state force is nothing but it is the product of mass and acceleration, and defined as a Newton, which is equal to kg multiplied by mass meters per second square. Okay. So force measurement methods, there are large number of force measurement methods. One is balancing the unknown force against a known gravitational force due to a standard mass scale and a balance work. Based on this principle, you can measure a force. We will see one by one. Applying unknown force to an elastic membrane. The elastic membrane means a spring or a beam, cantilever beam, or a load cell. On that one, you people are applying an unknown force and trying to measure the output of that particular thing. That results on a calibrated force scale, it will try to directly reflect in terms of output that how much unknown force you have applied. In that proportion, you are going to get the resultant output. Now, if you are interested to measure that output, at that time, what is going to happen? You have to use some secondary transducer to measure that output which you have applied, or unknown force which you have applied on the unknown device. Okay, that is nothing but spring, beam, cantilever. We will go thoroughly. But this point we people are supposed to study. Third one is translating the force to a fluid pressure and then measuring the resultant pressure. That is hydraulic, pneumatic, load cell. So work on this principle. So you people have seen many more devices that are operated using pneumatic or hydraulic machineries are there. So hydraulic one is much more powerful. So depending on that, and one of the example, that is deadweight tester, is the best example which we people are using in our laboratory also for the calibration of pressure gauges. But there also, if you are applying some weight on that dead weight tester, means you are exerting some force on the dead weight tester, and again the reverse uh, force you people are applying to the liquid, that will try to generate the output. As soon as the weight gets lifted, you people will consider that particular pressure, and that pressure is calibrated in terms of your required output. That is the part of pressure, but you can consider the example of force measurement in this aspect also. Then applying a force to a known mass and then measuring the resultant acceleration, how much acceleration you people are getting. And the last one is balancing force against a magnetic force, which is developed by interaction of a magnet and a current path. So one by one, we people will go. Weight measurement. What is the weight measurement? You people have seen many more times, as you many more are from pharmaceutical background. So I would like to show you this type of weight measuring instrument we people are having, and this is the handle. If you try to apply some standard weight of 1 kg at this particular place and unknown weight on this particular uh, disc, so when it get balanced, you people are saying that this weight and this weight is equal. But technically, when you people are trying to assume the consideration, the at when there is a no mean that has been applied at one of the disk, at that time this one will try to slightly move in the downward direction depending upon how much weight you have applied, and this will try to move in the upward direction. What it indicates? It indicates that force has been exerted more on this particular part and no force is exerted on this one. So the resultant output generated will be like this. This will move in the downward direction and this will move in the upward direction. So actually how that concept is incorporated, that I was explaining depending upon this particular concept for force measurement. So scale and balances, that is equal arm beam balance scale, unequal arm beam balance scale, then multi-lever platform scale, pendulum uh, scale, then elastic force meter, that is spring scale. Then there are large number of load cells also. Strain gauge load cell is hydraulic load cell, pneumatic load cell, LVDT. So these are nothing but these are some of the devices that can be used for the measuring for the weight measure. So equal arm, one by one we people are going to see. So if you try to visualize a equal arm type of pressure measurement, this is the force that has been exerted. So weight W1, weight W2, and when your weight W1 is equal to weight W2, at that time the scale is providing you a null deflection on the pointer. But here if you try to see your I1 or length 1 and length 2, both are equal to each other and both are suspended in a similar manner of a same material. So here it has been specified that weight 1 multiplied by product of weight 1 and length 1 is equal to